Okay, let's find the inverse Laplace transform of this really complicated problem here. So ideally, if we have a quadratic in the denominator here, we would like that to factor. If it factors, these problems are much easier. We would factor, use partial fraction decomposition to split into two separate fractions, and then each one would give us an exponential. Those are pretty easy. This denominator does not factor, so we can't do that. So we're going to have to use completing the square. And these are what we're shooting for here. Anytime the denominator won't factor and you have to use completing the square, you're going to get these exponentials times sines and cosines. So I'm shooting for fractions that look like these. Notice with the sine one, I don't have an s on top. With the cosine I do, and in fact it's not just an s, it's an s minus a. Okay, so let's complete the square in the denominator. So I've got s squared minus 6s plus 10. I want to take half of that middle guy. Half of 6 is 3. Square that. 3 squared is 9. Add and subtract that in my expression, because I want to keep everything balanced. I want it to still be the same expression. Half of 6 squared, add and subtract. Then the first three are a perfect square trinomial. They factor s minus 3 squared. Negative 9 plus 10 is plus 1. So now my denominator looks like this. So a is 3, b is 1. That's what we're shooting for. Okay, so now again, there are a couple of different ways we could do this. I find this way the easiest. Go ahead and split up the fraction. Split up the numerator. You're allowed to do that with numerators. We get 5s over that denominator plus 4 over the denominator. This piece here already pretty much looks like this. So let's deal with him first. He's going to be a little easier. So I call that number 2. I'm trying to make it look like this. So whatever number is right here is b squared. I want just b up there. If I had a 25 right there, I would need to have a 5 on top. I've got a 1, so b is 1 squared is 1, so b is 1. I need just a 1 on top, so I can pull that 4 out in front. Remember, the Laplace transform is a linear operator, so constants can be pulled out, either going forward or doing the inverse. So pull the 4 out. Now we fit this pattern exactly. A is 3, b is 1. So the inverse Laplace transform of that will be 4. That just comes along for the ride. E to the negative at sine of bt. Okay, now let's deal with this guy. He's going to be a little more challenging. Remember, I'm shooting for this. I need an s minus a on top. I've got my s. I don't have the minus a. Okay, so we're shooting for something that looks like this. First, I would pull that 5 off the front. Now I have an s minus 3 squared here. I need an s minus 3 on top. So how am I going to get that? By subtracting 3 and adding 3. Keeping in mind I've got this 5 multiplying the whole thing. That 5 is going to come along at every step. Can't forget about him. That's a common mistake, is forgetting that 5. Okay, now I can group the top as the s minus 3 over stuff plus just the 3 over the stuff. So split up the top. That piece right there is going to give me a cosine. This guy here doesn't have an s on top. He's going to give me another sine. I'm going to end up with sines from both parts that I'll have to then add together at the end. Don't forget the 5 out front. Okay, so I went ahead and distributed the 5 here and said I've got 5 of these and 15 of these. Because remember, with the sine ones, I want just a b on top. That guy there is a cosine. That guy there is another sine. So we get the inverse Laplace transform. We're only still doing, this is all just this first section here. His inverse Laplace transform will be this. Then I need to combine those two together. So from the first one, I had 4 of the sine terms. Altogether, I'll have 19 of the sine terms. So here's the final answer.